In the previous class, we were discussing how to determine the resultant of a general force system, right? So what are the various steps involved in determining the resultant of a general force system? The first step is, you can note down these steps. Resolve each force into X and Y components. Then you take algebraic sum of all X components of the forces and algebraic sum of all Y components. Then you can have the magnitude of resultant by square root of summation fx square plus summation fy square. Then direction of resultant tan inverse summation fy upon summation fx. This is with respect to x-axis. Now sense of the resultant that you can get from the signs of summation fx and summation fy. Then you have to find out the position of resultant, where it is acting. For that, what you have to do? Select any reference point in the plane and you take algebraic sum of the moments of all the forces about that point. Okay. Then you can find out the position of resultant either by calculating the perpendicular distance of the line of action of resultant with respect to that reference point, or by calculating the horizontal distance x or vertical distance y. So to locate the position of resultant with respect to that point, with respect to the selected point, you can calculate any of these three distances. Perpendicular distance d given by that moment upon resultant. Horizontal distance x given by that moment upon summation fy, y component of resultant, or the vertical distance y moment upon the x component of resultant, that is summation fx. Understood? No.
Yes, sir.
Yes, sir.
Yes, sir.
Very good. So to find out the position of resultant, you can calculate either d, x or y. Sometimes in the statement itself, it will be asked, determine where the line of action of resultant intersects the x and y axis. That means you have to calculate the distance x and y. Right?
Yes, sir.
And let us solve examples. Three forces of magnitude 100 Newton each are acting along the sides of an equilateral triangle as shown in figure. Determine the resultant in magnitude and direction with reference to point A. point to be noted with reference to point A. So this is the given figure. It is said that equilateral triangle. So all these angles are 60 degrees and the size is 3 meters. So you have to find out the magnitude and direction of the resultant with reference to point A. So first what you have to do, you have to resolve each force into XY components, right? So this 100 Newton, which is acting at A, making an angle of 60 degrees with the horizontal. See, all these three forces are acting along the sides of the triangle, along the side AB, along BC, and along CA. So the X component of this 100 Newton, which is acting at A, will be 100 cos 60. The Y component, which is downwards, 100 sin 60. And this 100 is acting horizontally at B. See, this 100 Newton, which is acting at C, by principle of transmissibility of forces, I will transfer from point C to point B along the same line of action. And then I will resolve into X and Y components. So this is 100 cos 60. We have this 100 sin 60. So instead of resolving at point C, I am resolving at point B. Why? That I will tell you in the next step why it is so. Now after resolving each force into XY components, then you take algebraic sum of X components of all the forces. So here it is minus 100 cos 60. Again, this component is acting towards left, minus 100 cos 60. And this 100 Newton is acting towards right. So it is plus 100. You are going to get this as 0. Okay. Then algebraic sum of all Y components. So the Y component of this 100 is acting downwards. So minus 100 sin 60. Y component of this 100 is acting upwards, plus 100 sin 60. And this 100 is acting horizontally, so its Y component will be 0. So this is equal to 0. That means the resultant force of this system is 0. So this is your answer?
No sir, moments भी नहीं देखने पड़ेंगे ना.
Right. Being it is not the concurrent force system, you have to check for the moment also. Right. And you are asked to find out the magnitude and direction of resultant with reference to point A. So let us take the algebraic sum of the moments of all the forces about point A. Resultant means it can be a force or moment, right? So in this particular case, the resultant force is 0. You have to check for the moment also. So taking moments about A, what is the moment of this 100 Newton which is acting at A?
0.
0. Line of act is passing through it. And what is the moment of this 100 Newton which is acting at B?
0.
Horizontally? 0. Again,
0.
the line of act is passing through it. Now the moment of this 100 Newton, to find out the moment, you have to take the algebraic sum of the X and Y components of this 100 Newton, right? Again, the x component of this 100 Newton, it is passing through point A. So the moment of x component will be 0.
0.
Whereas the moment of y component is anti-clockwise.
300
Right.
sine 60.
Right. So it is 100 sine 60 into the perpendicular distance is 3 meters.
Yes.
And it is anti-clockwise. So this will be 259.81 Newton meter anti-clockwise. So this is our resultant. Magnitude of resultant is 259.81 Newton meter. The sense or direction of resultant, here it is a moment, so it is anti-clockwise. So that means you can replace all those three forces with an anti-clockwise couple of magnitude 259.81 Newton meter. So this is the resultant of the given system. Please note down this example. Forces as shown and a couple M are applied to an angle bracket. Determine the moment of couple M if the line of action of resultant of this system is to pass through point B and point C. This is the given figure. So it is said that in the statement there are two parts. So the first part is resultant of this system is to pass. The line of action of resultant of this system is to pass through point B. Now see, when the line of action of resultant is passing through point B, what is its moment about point B?
0.
0. So as per Verigna's theorem, the algebraic sum of the moments of all forces about point B is equal to moment of resultant about the same point, which is equal to 0, because the perpendicular distance is 0. Line of action is passing through it. Right? So now let us take the algebraic sum of the moments of all these forces about point B. So no need to resolve this force, being we are taking moments. Tell me now, what is the moment of this couple M about point B? Moment of couple M about point B.
Same, sir.
Same.
It is M only.
M itself.
M itself.
Sense is anti-clockwise because the moment of couple is always constant. It is independent of the point about which it is taken. Whether you take A, B or C, it remains plus M. It is not M into 300, right? M itself is the moment. Now what is moment of this 50 Newton, which is acting downwards about point B? Sense is
Anti-clockwise.
anti-clockwise. So it is plus 50 into 300. Right? Perpendicular distance. What is moment of 125 about B?
0.
0.
0.
Moment of this horizontal 200 about B? Sense is
Minus 200.
clockwise.
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 So minus
Minus
200 into 200.
200.
This is equal to 0. So you will get the value of couple. This as 25,000, right? Newton
Yes, sir.
Yes, sir.
millimeter.
Millimeter.
That means 25 Newton meter anti-clockwise. Now the second part. When the line of action of resultant is to pass through point C. Taking algebraic sum of the moments of all the forces about point C is equal to 0, being line of action is passing through it, line of action of resultant. Now the moment of this couple M is plus M, moment of 50 anti-clockwise plus 50 into 300, then a moment of X component of 125. So it is 125 cos 60.
Clockwise.
Right. So about point C, moment of horizontal component is clockwise, minus 125 cos 60 into perpendicular distance is 200. And a moment of vertical component is 0, line of action is passing through it. Moment of this 200 is also 0 about point C. This is equal to 0. Value of M. Minus
Minus 25.
Minus 2500.
minus 2500.
Minus 2500 Newton millimeter. 100 Newton
Right.
millimeter.
So it is 2.5 Newton meter clockwise. Right? Meaning it is minus clockwise. Please note down this. Four forces are acting on a triangle ABC are shown in figure. The sum of moments of these forces at point C is 2000 Newton millimeter clockwise. If the resultant of the force system is in horizontal direction, find its magnitude and point of application. Conditions are given. One is the sum of moments of these forces about point C, nothing but summation MC is equal to 2000 Newton millimeter clockwise, means minus. Second condition is if the resultant of the force system is in horizontal direction, resultant force is in horizontal direction. So what is your conclusion? If the resultant is in horizontal direction, its vertical component is
0.
0. And its horizontal component itself is the resultant. So summation Fy is 0, summation Fx is R. So using these two conditions, you can find out the magnitudes of P and Q in the figure. So once you get the magnitudes of P and Q, you can easily find out the resultant. So this is the given figure. So it is angle alpha. Let us say This point is B. From the right angle triangle ADC, alpha is equal to tan inverse 120 upon 160. This is 36.87. Right? So
Yes,
the
sir.
x component of this 10 cos 36.87. Y component downwards 10 sin 36.87. So the first condition is the algebraic sum of the moments of the forces about point C is minus 2000. It is given. Now taking algebraic sum of the moments of all forces about point C. What is moment of this 20 Newton about point C? It is creating anti-clockwise sense. So it is 20 into 160 perpendicular distance. Moment of Q, which is acting vertically upwards, creating clockwise sense, minus Q into again 160. Moment of horizontal force P, creating clockwise sense, minus P into what is the perpendicular distance?
120.
120. And the moment of this 10 Newton about point C is 0, is equal to 0. Say equation 1. The second condition is that the resultant is acting horizontal. That means the vertical component of resultant is 0.
Sir, in equation 1 is equal to 2000, na?
Minus
2000.
Sorry,
Minus.
minus 2000.
minus 2000.
2000.
Right,
Yes, sir.
minus 2000. So it is 20 acting downwards, minus 20. Q is acting upwards, plus Q. Y component of P is 0. Y component of 10 is minus 10 sine 36.87. Right? This is equal to 0. So solving these two equations, you will get the values of P and Q.
Q is 26 and P is 8.66 Newton.
36. This is 8.67. Now to find out the magnitude of resultant, summation Fx is equal to R. That is equal to plus P plus 10 cos 36.87. So
16.67.
16.67 Newton acting horizontally towards right. So we have the magnitude of the resultant. Now you have to find out the point of application, where it is acting. So how do you find out that?
Moment divided by
Upon result.
Right. Moment divided by force. So now we are converting the given system into a simple system with one force and one moment at point C. What is that one force? Resultant force 16.67, and that one moment is resultant moment. This is summation MC minus 2000. So it is clockwise moment, summation MC 2000. So when this force and moment are combined, this force will be transferred parallelly by distance d, given by d is equal to moment upon force. So it is 2000 upon 16.67.
One 9.97.
Say 120.
120. Okay.
120 millimeters. Now you tell me where the resultant is acting.
Sir, it will be downwards, right?
No, it will be upwards only. Why? Because here the sense of moment is clockwise, na?
Yes.
2000 Newton clockwise. So if it transferred the above,
Yes, sir,
then only
clockwise.
it will create clockwise.
Yes, sir, got it.
So now you tell me the point of application of resultant. We know that it is acting at a distance 120 millimeters from C, but where?
At point A.
Right. So it is acting at point A because that resultant has to act within this body, na? It cannot act outside the body. So by principle of transmissibility of forces, you can transfer this resultant along the same line of action to point A because it is given that this distance is 120. Here it is 120.
Yes, sir.
So the point of application of resultant is A. That is not on this. Three forces and a couple are applied to an angle bracket. So find the resultant of the system of forces. Then locate the points where the line of action of resultant intersects the line AB and the line BC. That means what you have to find out here, locate the points where the line of action of resultant intersects line AB and BC means simply you have to find out the values of X and Y with respect to point B. Okay. So where the line of action of intersects line AB and BC, that means with respect to point B, you have to find out the horizontal distance and vertical distance. So this is the given figure. To find out the resultant force, first you have to resolve each force into X and Y components. So resolving this into X component, we have 30 cos 50 30 sin 50. Then you have to take algebraic sum of all X components. So this couple 90 Newton centimeter will not come into picture while taking summation Fx, summation Fy, right? So you have 30 cos 50 minus 60. So it is minus 40.72. So 40.72 Newton acting towards left. Then summation Fy minus 25 plus 30 sine 50 minus 2.02. So it is 2.02 Newton acting vertically downwards. Then you have magnitude of resultant. Square root of summation fx square plus summation fy square. Direction of resultant. Tan inverse summation fy upon summation fx. 40.77 and theta is 2.84. This is with respect to x. So it is acting in which quadrant?
Fourth.
Third.
Third, no?
Third.
Summation
Yeah,
fx
third.
towards
Sorry.
left,
Third
summation fy downwards. So it is third quadrant.
Sorry. Yes.
With respect to x theta. That means we are replacing the given system of forces with one force and one moment at point B. That force is resultant force making an angle theta with horizontal. And what is that moment? That you have to find out with respect to point B. So taking algebraic sum of the moments of all forces about point B. What is moment of this couple? 90 Newton centimeter. Simply plus 90. So moment of 25, again it is anti-clockwise, plus 25 into 60. Moment of 30 is 0. Moment of 60 is clockwise. So it is minus 60 into 11. Newton centimeter clockwise. We are getting minus. So we are having clockwise moment. That is summation MB as 170 Newton centimeter. Now, when this force and moment are combined, force will be transferred parallelly through a distance D, right? Perpendicular distance D. That D is given by summation MB upon R. But we are not interested in this D. You are asked to find out where the line of action of this resultant intersects line AB and the line BC. That means with respect to point B, you have this distance as horizontal distance X and vertical distance Y, perpendicular distance D. Are you following me? So with respect to point B, you can locate the position of resultant either by calculating perpendicular distance D, horizontal distance X, vertical distance Y. So X is given by moment,
M by sigma 1.
right? summation Fy, whereas y is equal to summation mb upon summation fx. You have 84.16 centimeter, 4.175.
Excuse me, sir.
Yes,
Sir, I didn't get that last part.
this x and y.
Sir.
So in this plane, so this is A, B, C, D. Some force system is acting on it, and the resultant of that force system is lying somewhere here. So from A at a perpendicular distance D, right? Now, as per Varignon's theorem, algebraic sum of the moments of all forces about point A is equal to moment of resultant. Now, I am taking this A as the reference point. With respect to A, say this is x-axis, y-axis. I am extending the line of action of resultant. So where the line of action of resultant intersects the x-axis, the distance of that point from A is x. Now, I am transferring the resultant by principle of transmissibility of forces along the same line of action to this point, say R. And then I am resolving this R into its x and y components, right? Now see here, the algebraic sum of the moments of all forces about point A is equal to moment of resultant, which is equal to algebraic sum of the x and y components of resultant about point A. Am I right? Rx and Ry are the x and y components of R. So sum of the moments of Rx and Ry about A is nothing but moment of R about A. Now what is moment of Rx about point A?
0.
0.
Because the line of action is passing through it. Now moment of Ry about A, Ry into X.
Ry into X.
So it is plus Ry into X. So this equation will give you X is equal to summation MA upon Ry, right?
Yes,
That
sir.
means it is summation MA upon what is Ry?
Ry
Y
is the Y.
component of resultant, algebraic sum of the Y components of all forces, summation
Fy.
Fy. Similarly, by transferring this resultant to this point on y-axis and then resolving into components, taking moments about A, you will find that y is equal to summation MA upon Rx. So that is summation MA upon summation Fx. So this x is the horizontal distance with respect to A, y is the vertical distance with respect to A, whereas you take only this. From this D is equal to summation MA upon R. Here what is D? Perpendicular distance from point A. So that way you can define the position of resultant with respect to the given point.
Yes, sir.
Okay.
Thank you, sir.
So with this, we have finished unit number 1, that is resolution and composition of forces.